Hi everyone, so today I'm going to be doing number 2, which is book problem 17.13. This has parts A and B, so I'm going to start with part A, which states, let f of x equal 1 for rational numbers x and f of x equal 0 for irrational numbers. Show f is discontinuous at every x and r. So for the proof, we're going to let x be an r. We can see that there exists two sequences such as x sub n and y sub n, where the limit x sub n equals the limit of y sub n, which equals x. So we have that x sub n is in the rational numbers for all n, and y is in the rational numbers for all n. This implies that the limit f of x sub n equals 1, and the limit of f of y sub n equals 0. But we can see that we have a contradiction. Since f is continuous at x, this means that our sequences f of x sub n and f of y sub n have the same limit, so this implies that f is discontinuous at x. Thus, if f of x equals 1 for rational numbers x and f of x equals 0 for irrational numbers, then f is discontinuous at every x in R. Part B states, let h of x equal x for rational numbers x and h of x equal 0 for irrational numbers. Show that h is continuous at x equals 0 and at no other point. So proof. To show that h is continuous at x equals 0, we will start by letting delta equal epsilon for any epsilon greater than 0. If x is rational, then we have that for any x minus 0 less than delta, then h of x minus h of 0 equals x less than delta, which equals epsilon. If x is irrational, then we know that h of x minus h of 0 equals 0, which is less than epsilon. This implies that h is continuous at 0. We will now show that h is discontinuous at any x that is not equal to 0. If x is rational, then we consider a sequence such as x sub n, where the limit x sub n equals x, and x sub n is in rational numbers for all n and n. From here, we see that the limit of h of x sub n equals 0, and 0 does not equal x. If x is irrational, then we can consider a sequence such as x sub n, where the limit of x sub n equals x, and x sub n is in the rational numbers for all n. So we can see that h sub x equals 0, and the limit of h of x sub n equals the limit of x sub n, which equals x, and x does not equal 0, so we arrive at a contradiction. This implies that in both cases, h is discontinuous at x at all the points where x does not equal 0. Thus, if h sub x equals x for rational numbers x, and h sub x equals 0 for irrational numbers, then h is discontinuous at x equals 0 and at no other